Here's some more examples of classifying number sets into numbers, or numbers into number sets. Okay. I set it up. All of these are real numbers. Remember, we're dealing with numbers we see, numbers that are on a number line. They're either irrational or they're rational. If they're rational, they're either integers, wholes, or naturals. So let's go ahead and take a look at a number. Number 1, 6,425. Well, I know it's a real number, so I'm going to use R. And I have to decide, is it rational or irrational? Well, it stops. It's not a decimal. It's not a square root. It's just a positive number. So I'm going to go with on this section. Now, is it a natural number? 1, 2, 3, 4, 5, 6. I'm not going to count all the way up to 6,425. So you get my point. Yes, it is a natural number. Is it a whole number? Is it positive? Yes. So that would be W. Is it an integer? Positive. Yes. So I'm going to use Z. And therefore, it is a rational number. Now let's go to number 2, pi. I told you pi is considered a real number, and we categorize it. Now I have to decide, is it rational or irrational or rational? And pi falls under your irrationals. It's one of those that's an exception. That's all I have to write because it is irrational. The reason it's irrational is because it never ends and it has no pattern to it. Actually, there's still a mega computer, a smart computer that's still trying to calculate it, and it hasn't stopped yet. Okay, on to number 3, 0. This is a tough one. Okay, I know it's a real number because it's on the number line. Is it irrational or rational? Does it go in group 1 or group 2? 0 is a rational number. Okay, remember, irrational numbers have no pattern and never end. Okay, so it's Q. Now, start from the bottom. Always start from the bottom, work your way up. Is it a natural number? Natural numbers begin with 1. 1, 2, 3, 4, 5. No, it's not a natural number. Is it a whole number? Whole numbers start at 0 and go toward the positive side of the number line. So 0, well, it is 0. So yes, it's a whole number. And if it's a whole number, then it's definitely an integer. And it's definitely a rational number, or Q. And we already have Q down. Here we see a square root. We have to solve the square root first. In order to solve the square root, I have to find the square root of both 25 and 36. 25 and 36 are perfect squares. The square, I'm going to take it individually. The square root of 25 is 5, and the square root of 36 is 6. And I have the answer 5, 6. If I were to calculate 5, 6 on the calculator, or 5 divided by 6, notice the 3, 3, 3, 3, 3, that is a pattern. So that would fall under group number 2 as rational numbers. So let's go ahead and start at the bottom of group number 2. Is it a natural number? 1, 2, 3, no. Is it a whole number? 0, 1, 2, 3, 4, 5, no. Is it an integer? Positive and negative whole numbers? No, it's a fraction. So the only one left is Q. That's a rational number, and it's definitely a real number. Let's go to the next one. I have to find the square root of 16. 16 is a perfect square. And if you're not sure, you can build a 4x4 cube. And that's a perfect square. Okay. The square root of 16 is 4. It's negative because my negative's on the outside. Now, we know it's a real number, -4. Does it go in group 1 or group 2? Is it irrational? Well, irrationals have no pattern and never end. No, so it makes sense, so it has to be rational. So I'm going to start at the bottom. Is it a natural number? 1, 2, 3, no. Is it a whole number? 0, 1, 2, 3, 4, no. Is it an integer? Well, it is negative, so it would be an integer. So I'm going to write z. And if it's integer, then it means, well, q. It's rational. And that's how you classify numbers.